The universe had a beginning, the Big Bang. But does it have an end? Scientists believe the universe is heading toward one of three possible fates: the Big Freeze, the Big Crunch, or the Big Rip. Each of these scenarios paints a different picture of how everything, stars, galaxies, even time itself, could eventually cease to exist. But which one is most likely? And what role does dark energy play in shaping our future? Let's dive deep into the ultimate fate of the universe. To understand how the universe might end, we first need to understand how it's evolving. Right now, the universe is expanding, and not just expanding, it's accelerating. This discovery shocked scientists in the late 20th century. Before that, many thought gravity would eventually slow down the expansion, maybe even reverse it. But when astronomers observed distant supernovae, they found that galaxies are moving away from each other faster and faster. What's causing this? A mysterious force known as dark energy. Dark energy makes up nearly 70% of the universe, yet we know almost nothing about it. Some scientists believe it's a property of space itself, a repulsive force that grows stronger as the universe expands. Others think it might be linked to an unknown quantum field or even multiple dimensions beyond our perception. Whatever it is, dark energy will determine the universe's ultimate fate. The first and most widely accepted theory is the Big Freeze, also known as heat death. If dark energy keeps pushing galaxies apart, they'll drift farther and farther away until their light can no longer reach us. As billions of years pass, new stars will stop forming, and the ones that already exist will burn out. The universe will become a cold, dark place where only black holes remain. But even black holes won't last forever. According to Stephen Hawking's theory of Hawking radiation, black holes slowly lose energy over time. Trillions of years from now, they will evaporate completely, leaving behind only a faint glow of background radiation. Eventually, even atoms themselves might decay, leaving the universe as a vast, empty void where nothing happens, no movement, no light, no life. Time, in a practical sense, would lose all meaning. This scenario is often called the death by entropy. Entropy is the measure of disorder in a system, and according to the laws of thermodynamics, the universe is always increasing in entropy. In other words, it's slowly running out of usable energy. If the Big Freeze happens, the universe won't end in an explosion or collapse, it will simply fade into nothingness, a quiet and endless darkness. But what if gravity wins in the end? That's where the Big Crunch comes in. Some scientists believe that dark energy might not be constant. What if it weakens over time? If that happens, gravity will start pulling galaxies back together, reversing the expansion. Over billions of years, the universe will shrink, galaxies will collide, and temperatures will rise as everything gets squeezed closer and closer. Eventually, all matter and energy will be crushed into a single, infinitely dense point, just like the singularity that started the Big Bang. Some theorists suggest that this could lead to a new Big Bang, creating a cycle of endless universes expanding and collapsing. This idea is known as the cyclic or oscillating universe. If true, it means our universe is just one of many in an eternal cosmic cycle. But there's a problem: the latest observations suggest that dark energy is not weakening. In fact, it seems to be getting stronger, making a Big Crunch less likely. However, if something fundamental about dark energy changes, the universe could still meet this fiery end. The most dramatic and terrifying scenario is the Big Rip. Unlike the Big Freeze or Big Crunch, where galaxies and stars still exist for billions of years, the Big Rip would destroy everything long before that. If dark energy continues to grow stronger over time, it won't just push galaxies apart, it will rip the universe to shreds. First, galaxies will drift away from each other. Then, billions of years later, the gravitational pull holding solar systems together will weaken, tearing planets from their stars. In the final moments, even individual atoms will be ripped apart. The universe won't just end, it will be completely shredded into nothingness. In this scenario, time and space itself would be destroyed, leaving behind, what? Nothing? Or something beyond human comprehension? The Big Rip is still a speculative idea, but if dark energy is increasing, it's a possibility we can't ignore. Scientists are currently studying distant supernovae and galaxy clusters to determine whether dark energy is truly constant or growing stronger over time. The answer could determine whether our universe will slowly fade, collapse, or be torn apart in a violent catastrophe. Will the universe freeze into eternal darkness? Will it collapse in a fiery rebirth? Or will it be torn apart by forces we barely understand? What do you think? Let me know in the comments. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mind-blowing science content. Until next time, keep wondering about the mysteries of the universe.